So hi, I am Roland Ginhawa from IT210G. So welcome to my channel. So first, from this vlog, which is we have to do a vlog for our tutorials for the knowledges that were learned from this chapter, which is a chapter 8, which is entitled Subnetting IP Networks. So as the titles as we can see the title, Subnetting IP Networks. So from this chapter, we have to know about this subnetting IP networks. So we have to do the all activities that we have here in the chapter 8 for us to understand all of the knowledges from this chapter. So I think we can start my channel. So from the chapter 8, which is the first activity was activity calculate the subnet mask basics. So from this activity, you are given a subnet mask in decimal format. So enter the binary representation of the subnet mask in the octet fields provided and additionally convert the mask to prefix citation format in the prefix citation field. From this octet fields, which is calculate the subnet mask. So we have here a subnet mask of 255 and 255 and 248 and 0. So we have to occupy these blanks, which is we have to do the subnet mask in binary of the 255, subnet mask of the 248, and the subnet mask of the 0. And after we have find the subnet mask in binary, we have to do the prefix notation. So let's answer. So to answer this 255, we have to add the position 1 8 16 32 64 and 128. So the total of all of the position from 1 to 128 is 255. So we have to add all the 1. And also for this 255, which is 1111. So from this, which is 248, so 128 plus 62 plus 32 plus 16 and plus 8, it will be a total of 248. So zero zero. So 000. So from the prefix citation of the subnet mask in binary, we have to add all the 1 here, which is which is 8, 16, 17, 18, 19, and 20. So let's check. 16, 17, 18, 19, 20, 21. Oh, I'm wrong. So it is 21 because all the 1 here is 21. So correct. So let's proceed to the next activity, which is from this activity, which is determine the number of bits to borrow. So you are given the number of the hosts that are needed to determine the subnet mask that would support the number of hosts. As specified, enter your answer in binary decimal and prefix notation format in the fields provided. So from this octet, we have host needed, the subnet mask binary, the subnet mask decimal, and the prefix notation. So first, we have to answer this. So 111 we have to provide this host, which is 25. So for this line, I think 5 zeros will be equals to 25 hosts needed from this, and from this subnet mask it is 255.255.255.224. And this is 27. The prefix notation is based on the numbers of 1 here. So 8 plus 8 plus 8, which is 24, plus 3, it is 27. So again, we have to occupy the host. We have to do here and have a 1,000 hosts needed. So 1111, then 1111, then here 6 1 and 2 zeros and all zeros. So this 10 zeros will occupy the 1,000 hosts needed. So the subnet mask of this one is this 255.255.252.0. So his prefix notation is 22 because 8 plus 8 plus 6 is 22. Then 1111, 1111, 1111, then 1111, then 111 and 7 zeros, which occupies the 75 hosts needed. And from this subnet mask decimal, which is 255.255.255.152, which is this. Then the prefix notation was 25, which is 8 plus 8 plus 8 plus 1 is equals to 25. So from the host needed 10, then 1111, 11111. So in here we have the 4 1 and 4 zeros, which is occupied by 10 hosts needed. So from the subnet mask, we have 255.255.255.240. So from the prefix notation, which is 8 plus 8 plus 8, which is 24 plus 4 equals to 28. So from the 500 hosts needed, we have 1111, 81, and 81, then 7, 1, and 0, 1, and 1, 0, then all of these zeros. So these 9 zeros will occupy the 500 hosts needed. So from the subnet mask, which is 255.255.254.0, and his prefix notation was 8 plus 8 plus 8 plus 8 is 16, then plus 7, which is 23. Then let's check. So all the subnet mask binary, subnet mask decimal, and the prefix notation is correct based on my answers. So let's proceed to the second activity, which is, so This is the next activity from the chapter 8, which is activity part 1, practicing VLSM. So from the table 1 uses regular subnetting to accommodate the network shown, and from the table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So from this table, which is new subnet mask decimal, which is this, because 255.255.255.192 is a subnet mask decimal. This is a new subnet mask which is from the decimal, and the next one is the first prefix notation, which is this is prefix notation 26. Then from this first full subnet range, which is 192.168.5.0, then 192.168.5.63, which is this is a first full subnet range. Then the next one is the second full subnet range, which is this 192.168.5.64, then 192.168.5.127. So the last one, which is the last full subnet range, which is 192.168.5.192. Then 192.168.5.255. So let's check this. So this is the answers for this activity. Then let's proceed to the figure 2. Which is from the second full subnet range. This is like the other activity from the figure 1. So from this second full subnet range, which is 626 from table 1, it is 192.168.5.64, then 192.168.5.127. Then from the new VLSM subnet mask decimal, we have as same as the figure 1. This is also the new VLSM subnet mask decimal. Then from the VLSM prefix notation, which is 27. Then the first full VLSM subnet range, which is this 192.168.5.64, then 192.168.95. So the last one is the last full VLSM subnet range, which is this last one, which is the 192.168.5.96 and then 192.168.5.127. So let's check. So all the answers are correct. So from this chapter 8, this is all the activities that we have to answer. So thank you for watching. Bye.